Hey, welcome back to Chapter 4, Section 4. Now, this is sort of out of sequence, so I put in the top right corner what your section should look like. This is going to be on textbook pages 292 through 294. We are going to learn to add and subtract unlike fractions, and really more specifically, the ones with integers. Same drill as always, you need to have lined paper. You should be writing everything that I write. You need to have your textbook, some pencils, colored pencils, your Bane, and the headphones. So in the first page here, you see textbook page 292. I went ahead and just put all the notes out there up front for you. So in section 4.4, you want to head your paper like this. The only thing that's missing from this is your name, date, and class period. And then you want key idea. To add two unlike fractions, meaning fractions with different denominators, you need to rename fractions using a least common denominator and add or subtract numerators following the integer rules, and then simplify. So on this next screen, you're going to see that we have a problem with like fractions. So we did some of that today, where you see it's 1/6 minus 4/6 equals, and in pink I have negative 3/6. So what that means is that we noticed that the denominators are the same, so I wrote same denominator, check. Now that the denominators are the same, we can focus on the numerators. So really we're just looking at 1 minus 4. Then we apply the integer rules, as you can see here, which remember, whenever you're subtracting an integer, it's just like adding its opposite. So 1 minus 4 would be 1 plus negative 4. Then you're going to keep the denominator the same, which we did. So we have negative 3 over 6. And now we are going to divide the top and bottom by 3 so that we can get negative 1/2. So that was just a quick review of how we are going to work with like fractions. All right, now that we know what we're going to be working on, let's go ahead and take a look at our next page. If you could go ahead and write these three things down, should just be a review for you. You should know how to convert these already, but I just want to go over it once. The three questions you need to ask yourself about fractions when you're adding or subtracting is number 1, are the denominators the same? Number 2, does the smaller denominator fit evenly into the larger denominator? And number 3, what is the smallest number that both fit into evenly? Hint, your 2, 3, 5 strategy. So I'll explain 2, 3, 5 strategy in just a moment, but at any time if you come to a yes, then you don't ask yourself the other two questions. So let's go ahead and take a look at the next page. So here we have are the denominators the same? So you want to write that again, and then we're going to write like fractions. So here you can see we have 1/6 minus 4/6 equals negative 3/6, and so that's the one that I've already shown you. So you just want to make sure that you have that example here. So now we paid attention and we have 1 minus 4 and we got the 1 plus negative 4, and now we have negative 1/2. So now for our next option, we are going to look at unlike fractions. So the unlike fractions, the example that we're going to have will be this one, and it says, does the smaller denominator fit evenly into the larger denominator? So you'll see unlike fractions, example 1, 1/2 plus 1/4. And you'll see my note off to the side. It says denominators are not the same, so 2 and 4 are obviously different, but see in blue I have 2 fits into 4 evenly. So now we're only going to rename one fraction. So as you can see on the next slide, I went ahead and did that. So we have 1/2 plus 1/4. Then we renamed 1/2 to make it 2/4, and again that's an equivalent fraction. So now our new problem is 2/4 plus 1/4, which gives you 3/4. I have given you a little note here to leave the 1/4 alone at the top. The next question you're going to see here says, what is the smallest number that both fit into evenly? So if you've already established that the denominators are not the same and that the small doesn't fit into the larger denominator evenly, now you want to look and see what the smallest number is that both fit into evenly. Now a lot of you are ready to go 10 times 4 immediately. That is literally your last resort. Before you do that, you want to look at the larger denominator, which is 10, and then you want to start multiplying by 2. So usually if you multiply by 2, and it's always got to be the larger one, because remember the smaller one won't work. So 10 times 2 is 20. And now you can say, oh look, 4 fits evenly into 20 also. So I've already found my least common denominator. So now it says to rename both fractions. On the next page, I've shown you how to do that. I have the original problem, 3/10 plus 3/4. And then we have 20ths. Notice I put the 20ths in blue. And then we had to say what we did to get from 10 to 20. We multiplied by 2, so we have to multiply by 2 on top, so we get 6/20ths. And then we do the same on the other side, but to get from 4 to 20, we have to multiply by 5. So we get 15/20ths. Then we go ahead and add, just like we would before, and we want to change it back into a mixed number. Now I want you to work on A, B, C, and D on your own. I've put the screenshot here, but you want to copy the problems. Go ahead and work on that now. So as you can see, you have 1/6 plus 2/3. So obviously the denominators are not the same. That was your first question. Second question is, does the small number fit into the large number? It does. 3 fits into 6 evenly. So remember from our notes that means we're only going to rename one of the fractions. So to rename this fraction, we're going to do 3 times 2, which gives me 6. And then I'll do the same on top. 2 times 2 will give me 4. So now I've renamed the fraction. So now I need to rewrite my problem. That needs to happen. So when I rewrite the problem, I write it as 1/6, because we leave that guy alone, plus 4/6 equals 5/6. Hopefully you did well on that one. You want to make sure to box your answer. So it should look like this when you're finished. So now for B, you have 9/10 plus -1/2. So the first thing again that you ask yourself, are my denominators the same? No, they're not. So then you want to ask yourself, does the small denominator 2 fit into 10 evenly? Well, it does. So just like before, we're only going to have to rename one denominator. So that means that we're going to leave 9/10 the same, and we are going to change -1/2 into having a denominator with the number 10. So now you ask yourself, well, how do I get from 2 to 10? Well, I need to multiply by 5. So now I'm going to do the same on top. Multiply by 5. Whoops, there we go. So now we have 5 times -1 gives me -5. So you're going to see you will have -5/10. So now you want to rewrite the problem. So rewriting the problem means that we leave 9/10 alone. So 9/10 plus parenthesis -5/10. And now we're just going to treat it like fractions. So we're going to just process the 9 plus -5. So the 10th stays the same because now we have our common denominator. And then we look at 9 plus -5 and we think about our integer rules. They're different signs. So we take the sign of the larger absolute value, which is positive, and then we find the difference. The difference between 9 and the difference in their absolute values. So the difference between 9 and 5 is going to be 4, because 4 plus 5 is 9, and our sign is positive. Now, one last thing you don't want to forget, you need to simplify. So for the simplifying here, we would divide them each by 2. So now you can see that we've divided by 2 on the top and the bottom so that we can simplify, and we get our final answer, which is going to be 2/5. Again, we want to look for C, and we see that 4 and 8 are the denominators, and 4 fits evenly into 8. So we're just going to go ahead and set this equal to 8 right here. Then we're going to ask ourselves, how do we get from 4 to 8? We multiply by 2. So we're going to do the same on top, multiply by 2. And on top now, where 1 times 2 is 2. So now we have 2/8 plus 2/8. And actually, I made a boo-boo. It was 3/8. So I'm going to erase that here. You want to fix that on your paper too. Now, 2/8 plus 3/8. So now we're going to rename our problem, or rewrite our problem rather. So now we use our new fraction over here, 2/8 plus 3/8. And we now have common denominators, so 2 plus 3 is 5. So your answer should be 5/8. Don't forget to put a box around it. So now you're looking at -1/3 plus -1/4. So the first thing we're going to ask ourselves, are the denominators the same? No, they're not. So now we're going to say, does the small one, 3, fit into 4 evenly? No, it doesn't, because 3 times 1 is 3, 3 times 2 is 6. So now we're over 4. So now we ask ourselves, okay, we've got 4, that's our larger denominator, and 4 times 2 is 8. Well, 3 doesn't fit into 8 evenly. So then we go 4 times 3. Oh, well, now we're already at the denominators multiplying by themselves. So now we're going to get 12. So we'll have 12 for each, because that is the least common denominator. And now we're going to have to change both. So to get from 3 to 12, we're going to multiply by 4. So now we're going to get 4 times -1 is going to give you -4. And now over here, we're going to ask ourselves to get from 4 to 12, we need to multiply by 3. So on top here, we're going to do the same, multiply by 3, and you'll see that -1 times 3 is going to be -3. So now we're going to rewrite our renamed fractions. So now we've got -4/12 that we're working with, plus -3/12 that we're working with, and a parenthesis. Now we're just going to apply our integer rules. When we have two numbers that have the same sign, negative, then you add them together and keep the sign. So 4 plus 3 is 7, so we're going to put a 7 here. We're going to keep the sign of negative, and the denominator stays 12. So your answer should be -7/12. How'd you do? Hopefully you did well. So now we're going to be looking at textbook page 293. So now when we look at this problem, we see -3/4 plus 5/9 in parentheses plus 7/4. Well, because this is addition, we could use the commutative property of addition to go ahead and regroup and change out the 7/4 and the 5/9. So we'll use the commutative property to switch the order and the associative property to regroup with the parentheses. So let's see how that looks. So as you can see, we went ahead and flip-flopped the order. We flipped, basically flipped 5/9 and -3/4, and then we regrouped. And the reason we did that is so that -3/4 and 7/4 could be combined before we had to find a common denominator. So let's go ahead and do that now. You can see we'll leave 5/9 alone, so 5/9 will be right over here. And then we're going to have our plus sign because that was part of the problem. And since we have a common denominator with the fourths, we now can say -3 plus 7 are signs are the same. I'm sorry, our signs are different. So we're going to take the sign of the larger absolute value, which means it's going to be positive, and we're going to find the difference. So 7 minus 3 is going to be 4. And remember, we keep our denominator the same. So now our new problem is 5/9 plus 4/4. And 4/4, hopefully, you recognize as being 1. So really, it's going to be 5/9 plus 1. And don't make this more complicated than it is. Whenever you have a whole number and a fraction and you're adding them together, that's all you need to do, 1 and 5/9. So you're all set with that example. Go ahead and try the on your own problems now. All right, so now we're looking at 2/5 plus 4/7 plus 3/5, where 4/7 and 3/5 are grouped together. So we want to regroup those guys. So we're going to leave our 2/5 where it's at, but we're now going to add that to the 3/5. So we're just going to move that guy right over here. And then we're going to regroup. We're going to group those guys together, plus, and now we're going to have our 4/7 that was there all along. So now we're going to look at this and we see 2/5 plus 3/5, and we got lucky again because that gives us 5/5. And 5/5 plus 4/7. And 5/5 actually turns out to be 1 whole plus 4/7 is exactly what we talked about last time, 1 and 4/7. So again, don't make it more complicated than it needs to be. So now you have -3/10 plus 5/8 plus 23/10. So we're going to once again regroup. So you should have regrouped and come up with this, -3/10 plus 23/10 plus 5/8. And then when you combine -3 and 23, you are going to get a new number, which will give you positive 20, because that's the difference, over 10. And now you're just going to copy your plus 5/8. And then you need to recognize, before you start doing a bunch of work, that 20 over 10 is going to give you 2. So once you get that 2 whole, now you have your answer of 2 and 5/8, because 2 plus 5/8 is 2 and 5/8. Now for example 3, you have -2/3 minus 1/2. Well, we're going to go ahead and treat this right away, just like the integers we know how to work on. The first thing that we are going to do is to get the denominator to be the same. So they are not the same. That was my first question. Second question is, does the small bit fit into the big? And it does not. And then once you start multiplying by 2, you get to 6. So the common denominator here should be 6. So we're going to set them both up next to 6. So now on the right here, I've said, okay, I need to multiply by 3 to get to 6 from 2, but I also need to multiply the 1 by 3. So now I don't want you to get confused with that being a negative number. It's not. It's minus 1/2. So for right now, we're going to have 1 times 3 is going to give us 3. So now we're going to also look over here, and in pink, I'm going to do 3 times 2 to get to 6. And now we do have that negative number. So 2 times -2 is going to give me -4. I'm going to rewrite my new problem. So I'll have -4/6, oops, minus 3/6. Now I'm going to apply the integer rules since I have the common denominator. So to apply the integer rules, we need to change the subtraction into addition. We're going to add the opposite. So now we're going to have -4/6, which we keep the same, plus, this is our changing, -3/6. So now, because remember you have to add the opposite to subtract, so now you have two numbers with the same sign, negative, so our answer is obviously going to be negative. And then we're going to combine. 4 plus 3 is 7, so -7/6, and that's going to actually be -1 and 1/6. And then you want to put a box around your answer. So now you want to try G, H, and I on your own. So here you have 5/8 minus 1/4. Don't mind my dog because he's being crazy. And you know that 8 is going to be the number that they both fit into. And now to get from 4 to 8, you're going to multiply by 2. Rocky! And so on top, I'm going to multiply by 2. He keeps barking every single time I push play. 1 times 2 is 2. And now I'm going to rewrite my problem. So I have 5/8 minus 2/8. And remember, you can do just the regular subtraction here. 5/8 minus 2/8 leaves you with 3/8. And then don't forget to box your answer. 3/4 minus 1/3. Immediately we notice the denominators are not the same. We can't really multiply by 2, but when we multiply by 3, we're right there with the common denominator of 12. So we're going to go ahead and put 12 next to both of them. Then to get from 3 to 12, we are going to multiply by 4. We'll do that on the top and the bottom. 4 times 1 is 4. Now we do the same on the other side. So our two new fractions are now going to be 9/12. Move that up a little bit. So 9/12 minus 4/12. And we can tell 9 minus 4 is going to be 5, so we can just subtract right across. So 9 minus 4 is 5, and we keep the denominator at 12. So we're just going to go ahead and put a box around that. Now we're looking at 1/2 minus -2/5. So we've got a lot going on here. The first thing we always want to do, though, is fix our denominator. So 2 does not go into 5 evenly. So 5 times 2 is 10, and 10 fits both of them. So let's go ahead and put 10s next to these. So now you can see the work here for that. And now we come up with our new renamed fractions, and those are 5/10 minus -4/10. And you don't want to forget the negative here, because remember, that changes the whole problem. So now we have another conversion that we have to do. We've got the denominators fixed, but now what we need to do is fix that subtraction, because now we're subtracting a negative. So we need to change some signs here. So originally I'm going to go ahead and write 5/10, because we're going to keep 5/10 the same. So 5/10 will stay the same. And then we're going to be changing the sign, because now we're going to add the opposite. So the opposite of -4/10 is going to be +4/10. So we're going to change that guy in there to a 4/10, just like this. And so now we've got 5 plus 4 is going to be equal to 9. So we have our final answer, which will be 9/10. Don't forget to put a box around it. So now we're going to be looking at textbook page 294. And on page 294, you're now solving real-world problems. So it says to add or subtract unlike fractions to solve real-world problems. So in here, you have to choose an operation. So it says use the table to find the fraction of the total population that has type A or type B blood. So because it says or, that means you really need to combine them together, because you need to look at all the ones that have type A, all the ones that have type B, and then if you have them both, then you're good. And those are the two numbers you want to add together. So you can see the work that has been done here for you right off to the side. I don't need you to recopy it. I just want you to take a look at it. And the final answer that they come up with is 26/50ths, which then becomes 13/25ths. So I just wanted you to take a look at that. I know you've done enough writing for this evening. Now you want to get out another sheet of paper. So now you're going to go ahead and head your paper 4.4 guided practice, textbook page 294. And then I would like you to work on numbers 1 through 7. So your assignment is 1 through 7. I have had some people doing number 8 as well, meaning they will get an extra point if number 8 is correct. So 1 through 7 is the assignment, but you can always do number 8 as well. Good luck, and I will see you tomorrow.